So computing has changed how we do many things today. And I want to give you an example from an area I particularly care about, and that is product design. So today, when we design products, let's say we are designing this car, it is actually amazingly supported by new computing tools. We have 3D editors. If you want to change anything about this car, for instance, the color, we can just use a single mouse click and we have a new appearance and can evaluate if we like this new design. Now in physical, this is actually not so easy. Yeah, if you wanted to actually change the color of your physical car, you would have to bring it into a garage. People would spend hours and hours repainting your car. It would be very expensive. So that's probably not something that you would do on a daily basis. So in my research, I'm asking the question, can we give physical objects the same capabilities as we have for digital objects or digital representations? With the goal that in the future, if you want to actually change the color of your physical car or any other product you own, you simply use a single click, for instance, on an app that you have on your phone, and it would change the appearance. So this is the topic I want to talk about today, which is reprogrammable appearances, and tell you more about why I think this has such a huge impact on future industries. So here's first a video of the technology we developed. So we have this smart material that we can spray onto any object. And then by shining light on it from an office projector, for instance, we can change the appearance of that object. It's fully reprogrammable, so we can always erase that appearance and program a new appearance onto the object. And you can see, since it's a sprayable material, you can put this onto a lot of different surfaces. So let's say you want to change the phone casing you carry around with to match your daily outfit, you can do this, or your shoe. And we have also worked with car companies to make some small-scale prototypes of how this could be applied to cars to make them color change, for instance, for applications such as car sharing, where each customer might want to have a different appearance. So just to show you this one more time in a few examples, this is the same phone case, so the same physical objects in all these images with different appearances. This is the same shoe. And this is the car one more time to show to you side by side with 2 programmed images on the side of the door. And we are currently working on expanding this to many other applications. So once you can think about textiles, right? A lot of us have, especially if you're like going to a trip, you pack a lot of shirts just to have different appearances you can wear on different days. How about you make this reprogrammable? You just throw it in the laundry, reprogram it, and then you have some new outfit for the next day. You can also imagine this to apply to walls or entire rooms. So if you have an event space, you have new people come in, you could actually reprogram the whole space here to, say, CSAIL Imagination in action. So before I go into the technical details, let me talk about the high-level vision. Like, why are we working on this? Why do we think this is so impactful? So the goal here really is to transform analog product manufacturing business into digital business. And let me tell you what I mean by this. So if you think about analog manufacturing business, right, they make the money by selling you the shirt or selling you the shoe for $100 or something like this. And honestly, I think in the future, you might even get the physical product for free. Yeah, so maybe the shoe company will send you the shoe in the mail, you get it for free, but then you actually have an app on your phone where you have a monthly subscription, and you pay for that monthly subscription to download new patterns that you can then use on a daily basis. So this will completely transform how these analog businesses make their revenue, and they now have to actually transform into digital business with all these different algorithms and features. So people always ask me, oh, this looks cool, but how does this actually work? So I want to give you like 1 or 2 minutes of technical background on this. So our work is based on these materials. They are called photochromic dyes, and they change color the moment they are activated by light of a specific wavelength. So here you can see 3 different samples in cyan, magenta, and yellow, going from transparent to being saturated. And then when we shine light of a different wavelength, they go back from being saturated to going transparent. The process is fully reprogrammable, as I said, so you can think of this as like a loop-based process depending on the wavelength you are shining. So these materials you can actually just buy. What's the big invention here? So normally when you buy them, they are single color only. So you can buy something that goes transparent to cyan or transparent to magenta, but there's no multicolor material that would give you all of these reprogrammable textures you just saw in the video. So how can we have multiple colors? And this is the invention my lab contributes to the area. We said, hey, let's take some inspiration from other color theory. Let's mix cyan, magenta, and yellow together in a single bottle. Yeah, so you just mix them all together and you get black, which is what you would expect from your CMYK inkjet printer that you may have at home or in your office. So now this magic bottle has all of the colors in it. So you see here on the slide, this is the same bottle with the same liquid in all of the pictures, but you see different colors. So the question is, how did we achieve this? How did we achieve this color change process? And this is what I'm going to talk about now. So let's say you wanted to go from black to red. What we have to do is we have to make the cyan in the bottle transparent, so that the eye only sees magenta and yellow saturated, and this gives you red as a result. Let's say you wanted to have a green color. We somehow have to make the magenta in the bottle transparent, so your eye only perceives cyan and yellow. So how can we make a single color channel in this bottle transparent? It's my last technical slide for this. I hope you can follow along. This is a wavelength chart, and you see the absorption spectra of each of the dyes. And if we shine light, for instance, at this wavelength, we will only make the cyan transparent in the bottle. If we shine light at these other wavelengths, we make roughly just the magenta transparent or the yellow transparent. So where do we get these different wavelengths from? Well, there are many different options. One, you can just use a normal projector. So actually a projector like we use for presentations has a red, green, and blue LED already integrated. And lucky for us, these actually align with the wavelengths we need to deactivate certain color channels in our bottle. So when you saw this video earlier, you actually see how we shine red, green, and blue light onto each pixel to go from black to a certain target color by deactivating cyan, magenta, and yellow for that specific target pixel. So there's fancy math behind this. We're at CSAIL, right? So if you're interested, we have a paper on our website where you can read more about the math behind this and the algorithm. I just want to briefly touch upon what's the forward-moving ideas for this technology. So right now it takes between 20 and 40 minutes to make a multicolor texture, but we already realized if we shine light of higher intensity, we can actually make this much faster. So if you double the light source energy, we can double the speed of the color change. We also tried out a grayscale version of this, so you can program a grayscale texture onto an object, and we can actually do this in under 1 minute. You can see this here. This is the phone case again. So if you're a designer and you want to iterate and see how does the texture really look on a product, you can actually have a very fast design iteration process where you get a new image on your object within 1 minute already. We also look into really cutting-edge technologies at the moment. So I talked about how these color change process is activated by light. But light does not only have to come from a projector, it can also come, for instance, from very small LEDs that are now actually possible to integrate into textile fibers. So you could imagine making a whole garment where you don't have to stand in front of a projector to recolor it, but the garment can just recolor itself, and then you turn off the LEDs and you can walk around with this new pattern on your clothing. Here's an early prototype of such a fiber. You can see we have the LEDs integrated. We have our color-changing coating on the outside, and on the right side you see a first color-changing fiber prototype. Yeah. We have also mixed this into 3D printing materials. So if you're in the area of manufacturing, there are lots of resin-based processes with single material only. If you mix in our material, we can now have a multi-color 3D printing process. So with this, I want to wrap up my talk, and I just want to emphasize this is just one example of how we are still lacking behind in the physical object space in terms of giving them the same capabilities as we have for the digital space. So programmable appearance is one. There are other very exciting avenues. If you go to our lab website, you can find more about our work. So what if we can give physical objects digital capabilities? It will completely change how we actually interact with the real world around us besides just looking at our computer screen. So with this, I want to thank you and see you soon.